See, we don't need to film at the backyard today because we figured out a way to actually film this video in my corridor. Okay, so welcome to investment appraisal class 4. In this class, we're going to be concluding the example we started, Jackpot Limited. Okay, so just as the word implies, payback period is the number of years it will take the investor to regain his money, right? His original investment. So to calculate payback period, all you need to do is to get the cash flows and the cumulative cash flows so that you can start to amortize or reduce the balance and know the particular year that they will regain their investment. So you have year, because you're looking for the year that they will get their money back. Then you have your cash flows and you have your cumulative cash flows. Okay, now the difference between payback period and discounted payback period is the discounting. Okay, so for if it is discounted payback period, it will be discounted cash flows. In that one, you're taking into consideration the time value of money. That makes sense. So what are our cash flows? Let's check, because I've rubbed off the board, but I believe that you still have it in your notes if you are following. Our cash flows in year 0, 1, 2, 3, 4, 5. We have our cash flows in year 1 to be 140,000. In year 1, 12,180. In year 2, 87,592. Year 3, 60,128. Year 4, 14,404. Year 5, 12,054. And don't forget that all these cash flows, they have thousands on top, so it means they are in millions. You understand? It means this is 12,180,000. So just put your abbreviated whatever on top. So your cumulative cash flows, so by year 0, 140,000, because nothing has been gained. But by year 1, this 140,000 will change. It will reduce. I mean, the negative 140,000 will reduce. So that's minus 140,000 plus 12,180, and that gives you minus 127,820. That's the cumulative. You can see it's reducing it, right? Then you add, they'll make another 87 by the end of year 2. So plus 87,592. So that will reduce the balance to what? Negative of 40,228. By year 3, by the end of year 3, they would have made 60,128. And look at it, still has to cover 40,228. So it means that what they are making, right, is more than what they are trying to cover, what they are trying to clear. I don't know if that makes sense. I might go over it again, right? So it means that they will regain their money in the middle of year 3, right? Because at year 0 is still a negative. By year 1, the negative reduced. By year 2, the negative reduced. By year 3, the negative will finish, because 60,126 can cover 40,228. Okay, so it is somewhere around what, 2 years and, right, 2 years and some months. Okay, so how do you get that some months? You say, what are they trying to clear? They are trying to clear 40,228 over what is available to clear what they are trying to clear, 60,128. Okay, that's how you get the number of months that is going to be added to that 2 years. You know, it makes sense that this is what they are trying to clear, 40,000, and then they have 60,000. So it's not going to wait till the end of year 3 before they will regain, before Jackpot Limited will regain this 40,000. Somewhere around 10. Let's calculate it. So you have 40,228 divided by 60,128, and that gives you 0.669. That's 0.7, right? So that would be 2.669 or 2.7 years, right? So to take them 2.7 years to regain their investment, or to have covered or to have recovered their investment. Does that make sense? It makes sense. So if you want to get this thing in months, right, this 2.7, just say 2 years plus 0.7 times 12 months. Okay, so 0.7 times 12 months, that will give you 8.4. So that's like 2 years and 8 months. But instead of you putting it in 2, just put 2.7 years. It's very acceptable. So I hope I didn't over explain and then you don't now get any point. I just hope you understand it. So that's how to calculate your payback period. Now to get your discounted payback period, you're going to do year, discounted cash flow, and cumulative discounted cash flow. The difference is the discounted. The difference is that you are considering the time value of money in that aspect. Okay, so you are trying to get your discounted payback period, which is what the V part of the question says. You know, they say you calculate MPV, IRR, MIRR, payback period, discounted payback period, and project duration. So we've done MPV and all others in the previous class, right? So that's why you need to watch all those previous classes if you have not watched them. And I don't even think they're up to 1 hour. So just invest in watching those previous classes so that you can have a proper understanding of these classes. Okay, so you have your discounted cash flows, and your discounted cash flows, which I believe will be in your own notes, right, from class 2. You have your discounted cash flows year 0, year 1, year 2, year 3, year 4, year 5. Year 0, of course, is 140,000. By year 1, your discounted cash flow was 10,974, 71,124, 43,954, 9,924, 7,148. Okay, so you now start to get your cumulative discount cash flow so that you know the year at which they will regain their investment. So you have minus 140,000 plus 10,974. Please ignore all the noise. So in year 0, of course, it will still be 140,000. By the end of year 1, their investments by the end of year 1, their investment to be regained would have reduced to 129,026, okay, plus 71,124. That gives you 57,902. By year 3, you can see what they will make. It's not even still enough to cover, so we can still step down, right? Plus 43,954. That gives you 13,948. Okay, you can see that even by year 4, we will still need to step down. Plus 9,924. That gives you 4,024, right? By year 5, can you see that? By year 5, the money that they will make in year 5, the discounted cash flows for year 5, is enough to cover this. So it is going to be what? 4 years plus what is to be covered, 4024, over what is available, 7148, right? So 4024 divided by 7148, that's 0.56. So that's 4.56 years. Okay, 4.56 years to recover their investment. Okay, so you can multiply by 12. That's that 0.56 by 12. So now how many months? So that's 4 years and 7 months. That's if you want to put it in months. 4 years and 7 months. So that is how to solve payback period and discounted payback period. It's very simple. Now let's go to project duration. Project duration. So project duration also looks at the number of years that it will take the investor to regain the original investment or the present value of the future cash flows. Okay, so there are 2 ways to calculate your project duration, which I'm going to explain first before solving, right? Because you really need to understand this project duration. You know, I told you in class 1, and I said it in also class 2, that these methods, some of them looks at the profitability, while some looks at the liquidity. You know, MPV, IRR, MIRR. This one, they look at the profitability of the investment. How profitable is it? Should we accept or reject? You know, how profitable? At the end of the day, this one, they take into consideration all the cash flows, and they want to know that, okay, at the end of the project life, is this project going to end up with a positive outcome or a negative outcome, right? But the other method, which is the payback period, the discounted payback period, and the project duration, they all look at what? The liquidity. They want to know how fast, how can I get the money sharp. Do I have to wait till the end of the project before recovering the investment? Okay, so that is what it looks at. So now we have done all those methods, and now we are talking about project duration. So I said that there are two ways of calculating project duration. Okay, in project duration, you are trying to recover either the original investment, which is the 140,000, or you are trying to recover the sum of present value of future cash flows. Okay, future cash flows, what you are expecting in the future, you want to get the present values, sum them up. Okay, so these are the denominators. So here, what the numerator here is what? The sum of weighted PV of future cash flows. I could actually write it in full, but I prefer to write them with signs so that it just goes straight to the point. Okay, so this is the sum of weighted PV of future cash flows. I'll explain it very well. Now, whenever you're trying to recover the original investment, use this R to this is how I learned it. I use this R to guide myself so I won't forget, and that's why I can actually teach now. Original investment, it means you are going to do what? You're going to discount with IRR, right? When you are trying to recover the sum of present value of the future cash flows, you are going to discount with cost of capital, which was 11%. Remember that the IRR here was what? 12.1%. What we solved in class 3, we got IRR to be 12.1%. Okay, so you can see that the numerators are the same, right? They are the same. It's the denominator that is different. And how do you know which formula to use? Right? How do you know which formula to use? It depends on the information given. So in this question now, the information that they gave you, he has what? He has the original investment, and he also has the sum of present value of the future cash flows, right? You know, in this example that they gave you also, you have your IRR. What if they didn't ask you to calculate IRR? What if they gave you only cost of capital? So, and they asked you to get project duration. So you know that this is the approach to use, okay? So when we are solving it, you understand. The summary of what I'm saying, that whenever you're asked to calculate your project duration, there are always two approaches. And in the first approach is to say what? Sum of weighted PV, sum of weighted present values of future cash flows, or just say sum of discounted cash flows over your original investment. That is, you are trying to recover what is underneath, the original investment. And whenever you are trying to recover your original investment, you are discounting the numerator with IRR, because for something to be present value, for you to have present value in something, it means there's a discounting, right? So it's IRR you are using to discount, okay? And the weighted here means that you are multiplying by the corresponding number of years, which you see when we are solving. Then I said the other approach, which is dependent on the information you're given, is when you're trying to regain the present value of the future cash flows. Okay, you are trying to regain the present value of the future cash flows. So if you are trying to regain the present value of the future cash flows, you are discounting the numerator with the cost of capital. Does that make sense? It makes sense. So now let's solve the project duration. Right? Let's solve the project duration. Okay, so let's use the first approach, discounting project duration. So let's use the first approach, discounting with IRR. When you are discounting with IRR, so you are trying to recover the original investment, Abi. So the formula, always write your formula so that you know what you're looking for when you start writing the formula. So we have sum of weighted present value of future cash flows. You can see how it's long. That's why I used to summarize it. Divided by original investment. Now when you write your formula, you now start asking yourself, which one do I have, which one do I not have? Original investment, you know that is what, 140,000. You have that. But do you have sum of weighted present value of future? No, you don't have. So you go and get it, right? Year 1, year 2, year 3, year 4, year 5. Your years, right? Then what are the cash flows in those years? You write the cash flows. You know, you would discount because you're trying to get the present value of the cash flows. You would discounting at what? At IRR. And the IRR we got in class 3, which we solved it to be 12.1%, right? Then you have your present values, right? And you now have your weighted present value. Does it make sense? It makes sense. So what are your cash flows? Check your notes because you've been in class. 12,180, 87,592, 60,128, 14,404, and 12,054. And they are all in thousands. Don't forget to put this stuff here always, okay? So you discount at 12.1%, right? So you need to put your discount factor, what you multiply by these cash flows to get the present value. So when you are discounting at 12.1% for year 1, that will be 1 plus, you know that formula, right? 1 plus R, that's 1 plus 12.1%. You won't write 12.1, it will be 0.121 raised to power minus 1. Then raised to power minus 2, then raised to power minus 3, like that. So for year 1, 1.121, no need to be writing plus, raised to power minus 1. Can you see that? That's 0.892. Raised to power minus 2, 0.796. Raised to power minus 3, 0.710. Raised to power minus 4, 0.633. Raised to power minus 5, 0.565. Can you see that? Then you now get your present values. Multiply. That's 12,180 times 0.892. That's 10,865. I'm just abbreviating everything. 10,865. Right? So multiply by year 1. This times 1, that will still give you 10,865. That's the meaning of weighted. If you have been following me from what's the name of that? Is it bond valuation class? Yes, from bond valuation class, you would have seen how I solved weighted. When you are weighing something, I am multiplying it by the corresponding year. Okay, so let's do this one also. 87,592 times 0.796 equals 69,723 times 2, right? That's 139,446. Now let's do for year 3, year 4, and year 5. Right. So now that you have done for year 3, 4, and 5, you get your sum of weighted PV, right? Sum of weighted present value or future cash flows. So when you add all of this, what will you get? Let's add that. That's 10,865 plus 139,446 plus 128,073 plus 36,471 plus 34,053. That gives us 348,908. This is highly abbreviated, as in it's highly what's the name of that? Approximated. It has been so approximated, okay? But it's just an estimation, so your answer should still fall within the range. Now, your project duration, which is the sum of weighted PV, which you have gotten to be 348,908, divided by original investment of how much? 140,000, and that gives you, just say divided by 140,000, that gives you 2.49 years. Okay, so that's how to calculate project duration from the first approach. In exam, don't go and calculate two approaches based on the information given. If they give you IRR, you estimate using IRR. If they give you cost of capital, you estimate using cost of capital. So me, I'm just doing IRR and cost of capital because we have both information in the question. So even if you're in the exam and you have both information in the question, it's what they are. You just pick one and do. Okay. So we are going to discount now using cost of capital. Okay, I know when you're discounting using cost of capital, what you're trying to look for at that point is your sum of present value of future cash flows. Okay, you know your sum of present value of your future cash flows is kind of equal to your original investment, because you don't want to get in the future the cash flows you get in the future. When you discount it, it should kind of equal your original investments. So if you think about it very well, it should make sense to you. So what you are trying to recover when you are discounting with cost of capital, which is the second approach, you are trying to get your sum of present value of future cash flows. That's this one here, right? So now let's discount its cost of capital. Cost of capital was given, remember, in class 2 as 11%. Remember, we got it using the Fisher's formula. Okay, so what are your cash flows? Am I rubbing off cash flows? I was rubbing it off. Okay, let me just rub everything so that we put it one by one, right? They are not the same anyway. Your cash flows, they remain the same as 12,180, 87,592, 60,128, 14,404, 12,054. Okay, so let's discount using 11%. If you remember, when we were trying to get MPV, we actually discounted using 11%, but let's still just do it again, so that it's not like I'm just manufacturing the figures from somewhere. So that's 1.11 raised to power minus 1, 0.901 raised to power minus 2, sharp, 0.812 raised to power minus 3, 0.731 raised to power minus 4, 0.659 raised to power minus 5, 0.593. Okay, so multiply to get the present values, and that will give you this. Okay, so to get the weighted present value, you start to multiply the present value by the corresponding years. That's this times 1, this times 2, like that. So you have 10,974, 71,124 times 2. That will give you 142,248, 43,954 times 3. That's 131,862, 99,24 times 4. That will give you 39,696, 71,48 times 5. That will give you 35,740, right? Yes, 35,740. So now you sum this weighted PV. Whatever you get here, that's your numerator, right? Then your denominator is whatever you get here. Makes sense? So simple. So let's just add up. So that gives you 360,520, right? Then when you add this up, you have 143,124. So now you come and get your project duration. So project duration will be equal to 360,520 divided by 143,124. So let's do that. 360,520 divided by answer. So that gives us 2.52 years, right? 2.52 years. Actually, it's meant to be very close. I think the project duration, what did we get? Was it 2.9 years or 2.7? I can't remember. But it's actually meant to be very close, like 2.5, between 2.5 and 2.7. Do you understand? So the reason for the far difference, so to say, is because of the approximation, okay, which is actually very normal. In the exam, you're not going to be calculating two approaches, it's just one approach. So as long as you're still within 2 point something, whether from 2.1 to 2.9, the answer is correct. The important thing, okay, is to get the concept and for your steps to be correct. Do you understand? So thank you so much for watching this video. We're going to proceed to class 5, where we will either solve another example or we'll just move straight to adjusted present value. I'm not sure. I have to check my jotter. Okay, so thank you so much for watching this video. Give it a like, share, and I'll see you in the next class. We are not done with investment appraisal yet. It's a very broad topic. Okay, thank you for watching, and don't forget to share this video with someone that is going to find it helpful. Okay, bye.